Okay, so in these problems, when they give you how to find the area of a region, okay, again, it's all about these formulas, how they bound it. That's why we spent time in some of these other chapters when we first started integration, talking about what bounds your region, because you don't want it to be unbounded. You can't find the area of it. So they gave us all of this information to help us. But what really is nice about what they've given us here is here's your A and B. Does that make sense? Okay. You still may need to graph it, though, because that will help you to figure out top, bottom, or right and left. So it's easier to graph the x is -1 type problem here first, because it's at the origin, and it's going down one, right one, down one, right one, down one, right one, up one, left one, up one, left one, up one, left one, and so on. So there is my straight line. Pretend that's straight. My board is really off today, but I don't have time to orientate it. Then with x squared plus 2, yeah, at 0 it's 2, and at 1 it's 3, okay? And this would be a curve that does this, right? Everybody agree? Do they overlap? No, that's why it's so important to understand the 0 and the 1 part. It starts here and ends here. So it's all this area right in here. Probably all the way down to here. So it's the area between the two curves where the x lines here, x equals 0 and x equals 1, bound it off and give you a sliver between the two of them. Does that make sense so far? So that gives you not only your A and B, but it tells you how to cut it off and make a dotted line on each side. So we're going to integrate. I'm going to minimize this. We're going to integrate from 0 to 1. And we got to figure out who's on top. Yeah, who's on top. Because we're supposed to do top minus bottom, right? So top's the curve. Everybody agree? So that's my quadratic. Minus my linear, because the linear one's on the bottom. So now that we've got that going, no, you simplify first because you want it to be in simplest form. Sometimes you can add like terms. Sometimes you might have to work out some power stuff. So this is x squared plus x plus 2 that we're taking the derivative and integrating, right? So won't that become x to the third over 3 plus x squared over 2 plus 2x? Everybody agree with that? Added 1 to the power each time. And we're going to put that in from 0 to 1. And I left those written as the fractions instead of putting the 1/3 in front of it because I'm getting ready to put a number in, and I just thought it's easier to put a number in if it's already all together. Because 1's 1/3, and 1's 1/2, and 1's going to be 2, and the other part's going to be 0. So whatever half plus a third plus 2 is. Well, let's see, isn't that 5, 6? If you get a common denominator. Won't that be 2, 6 plus 3, 6? If you get a common denominator. Plus 2. So that's 2 and 5, 6. Or 7, not 27. 17 sixes. So you can decide how you need to add that up. But if you have to do it by hand, you need to go to common denominator, add your two fractions together, and make it a mixed number that you can turn back to an improper fraction.
Since it's area, do we have to put units on it?
No. For these, we don't. All right. So let's look at another example. And sometimes, y'all, when you're doing this, if you feel like you don't want to graph the whole entire graph, you could, graph less of it. For example, I didn't need any of this negative part over here. I could have just graphed from 0 to 1. It's up to you how much of the graph you show, but you definitely need to put those two dotted lines in. That's very important.
The next one we have to graph all of it.
Yeah, this one will have to graph more because they're using the x-axis as one of your graph parts. So since 0 for a function is the x-axis, that means it's either all, well, it could be all above, all below, or half and half, which means that we'd have something like that other one where you have to set up two of them. And because I don't have any other information, I'm just going to plot a few points and see where it goes. So if I put 0 in, don't I get 0? Okay. If you put 1 in, you get -5. Would everybody agree with that? If you put in 2, it's going to get really big. Let's put in -1. If you put in -1, you'll get 1 plus 6, which would be 7. Everybody agree? 6, 7. Well, I might have made a math error on that one. That don't look right. Oh, I probably need more positive. It's going to open up. I probably need more positive. Well, let's factor this. Maybe that'll shorten the process a little. So x and x minus 6 are your x-intercepts. We already had one of them. There's our other one. Does everybody think that's probably a good idea now? So now, where do you think we're finding the area if it has to be the area between the two curves? Okay. So we're looking for this down here because I got to be between the dotted line and the curve. Now, not that that's supposed to be a dotted line. I made it dotted so you could see it. It's really supposed to be a solid line. So 0 to 6. Who is on top? G of x. So that means 0 minus my other function. Now, when you plug that in, you want that to always be in the multiplied together format, not the factored format. The factored format's just great for getting x-intercepts. And you could go to your calculator, y'all, and get lots of points if you needed it. That's right. That's just distributing a negative. So therefore, we have negative x squared plus 6x that we're going to integrate. And then we'll plug in 0 to 6. Negative 1/3. What? 3x squared? Does that sound right? And we're going to put in 0 to 6. Now, we know when we put 0 in that, we're going to get 0. So we just got to really work out 6. Six cubed is 216. 216 divided by 3 is 72. So that's negative 72. 36 times 3 is 8. Carry a 1, 108. So 108, and that makes 36. If I did the math right. All right. Now, what if you weren't sure about what it's doing? You could always use your calculator to help you some, y'all. If you can't figure out, like, what you need to see, you can always graph it on the calculator and see if that helps. And that might be something that would help sometimes. For example, in number 3, well, crazy board. It's not hard to graph x plus 1. But making it cross that other graph might be another case. For example, if you plot 1 on the y-axis and go up 1 over 1, up 1 over 1, or down 1, left 1, down 1, left 1, you get a great line. But making it cross the square root of 3x plus 1 might be a different story. For example, I can't plug any negative numbers in that. Can someone tell me why? That's right. So if I put in 0, I get 1. I'm going to do that in a different color. So that point's already crossing. If I put in 1, I get the square root of 3 plus 1, which is 1.7 plus 1, which is 2.7. And if I put in 2, I get the square root of 6, which is more than 2, plus that would be 3 point something. And if I put in 3, I get 9, and the square root of 9 is 3, plus 1 is 4. It actually does. 3 is 4 in both of them. So if you weren't sure where this intersection was, and you were absolutely sure that you might have graphed something wrong, you could always put it y1, y2, and make the intersection off your calculator to make sure that that graph crossed where you think it did, because this one does cross at 3, 4, because you do get 3, 4 no matter which one you put it in. And this one's 0, 1. So now I know I'm going to integrate from 0 to 3, because I want this sliver right here. Who's on top? All right, so the square root of 3x plus 1 is on top because it's the curve, minus the linear because it's on the bottom, because it's the one that's straight. So it's clear to see that the top is a curve and the bottom is straight. And about all I can do is distribute and add that ones together, right? So I got the square root of 3x minus x. Well, the ones cancel out. That's good. One less thing to deal with. Now remember, when you integrate, you got to have the dx, right? So thinking of it, when you integrate 3x, we're missing the derivative of the inside, are we not? Wouldn't I need a 3 over here? I don't have one, so I need a 1/3. So it's 1/3. Half power goes to what? When you add 1 to the power and put, flip and all that, what's half power go to? All right, 2/3 and 3/2. All right, and then x is just going to become negative x squared over 2. Everybody agree with that? So 1/3 times 2/3, 2/9, x to the 3/2 minus x squared over 2, all going to be integrated from 0 to 3. Now we know 0 is going to make 0. So we just got to work out what 3 is. I lost something somewhere. Yeah, I lost a 3 right here, y'all. It was 3x squared to the 3/2 power here. Parentheses around that. No, it's not 6/9. It's just when I brought this down, I forgot to put the 3 back in the power problem. So this is 3x to the 3/2. So when I put 3 times 3 in there, that's 9. Now how do you take 9 to the 3/2 power? Well, first you change it back to a radical. Do you know the square root of 9? Would you like to do that before you cube it? Because you can do it either way. Yeah, I think we would. Well, it's easy to take square root of 9 and then cube it. It's 27. And then 27 times 2/9 is going to be 6. So I see where you got your 6 from. And then minus 9/2. That's 12/2 minus 9/2 is 3/2. So the final answer to this question is 3/2. So that's why it's important to be careful and keep up with that inside, because it affects what you're taking the radical of. If I didn't have that, I would have to get a decimal answer to this question. But I was able to have 2 3s in there when I plugged a 3 in, and that made it square rootable.
Oh, Ms. Johnson?
Mm-hmm.
Right there, when you wrote 1/3 integrate square root of 3x, 3dx, did you skip an x right there?
No. The derivative of 3x is 3. So that goes away, and that's why we needed the 1/3. Yeah, this x is inside of. I'm just talking about this part. I hadn't got that part yet. Okay, this part I did this because I had to see the du work. I integrated that without writing it down. If you want to put it in here, you do it like this. It'll be over there by itself.
Okay. Yeah. That's why.
Because it was chain rule. I had to do some separate work there on the first part because I could do the second part in my head. Because we can all do power rule without having to show a lot of work. But yes, you probably need to show that because you'll probably wonder later, where'd that come from?
I was like, I don't understand how we.
All right, so we're about to finish this up, y'all, with doing some work by hand by doing one example of y. And y is a little bit harder. Just a little bit. So I'll try to slow down just a little bit for you. Number one of the reasons why y is a little bit harder, because in order to figure out who's on top, you have to graph it, and you don't have x's to plug in. You've got y's to plug in to get x's. And that makes it just a little bit harder. But we know we're doing y from -1 to 2, so that's good. Because if we're doing it from -1 to 2, at least we know what y's we needed to plug in. Now, when we set up our axis work here, we know we're going from -1 up to 2. Everybody with me so far? And when I say g of y is equal to 0, that's a vertical line. Just like earlier when I had f of x equals 0 was a horizontal line, anything about g of y equals 0 means it must be x equals, and so that's x equals 0. So there's where that line is. Now we got to figure out where the other one is. And to do that, you probably want a table. And this table is going to have -1, 0, 1, and 2 in the y column, which is what's weird about this. I got to calculate my x's. So I just plug each one of those into the function. -1 squared plus 1 is going to be 2. If I plug in 0, I'm going to get 1. If I plug in 1, I'm going to get 2. And if I plug in 2, 2 squared plus 1 is 5. So you've got to plug these y values in and get your x values. Because they gave you y's, not x's. But you still plot them normally. Go over 2, down -1. Go over to 1, 0. Go to 2, 1. And go to 5, 2. So here's my area.
When you go to the left side of the wax, it says -1.
That's y. Yeah. See, that's what makes it hard. It's a totally reverse in our brain. We've never actually graphed functions of y before because they're really not functions. Because does that pass the vertical line test? No. Well, that's right. We're doing a little different. So that's the hardest part about this is when it's y's. It's just a little trickier. Who is further to the right, the curve or 0? The curve. So we'll have y squared plus 1, minus 0 dy. Now I have to write that in there so I can say I've wrote my notation, even though that second function is 0. I can ignore that and we can integrate it. Won't that be y cubed over 3 plus y? Power rule, right? You integrate y's just like you do x's. It's just power rule. But this time it's going to take more math because I actually have numbers to plug in for one of them that I didn't have before. Right? That's right. That's 8/3 plus 2 minus what's -1/3 to the third power over 3 is going to be also negative, isn't it? So that's going to be positive 1/3. And negative and negative make a positive 1. Because anything to the third power is going to be negative, and that subtraction sign in front of it is going to change it. So that's 9/3 plus 3. That's 3 plus 3 equals 6. Right? 9/3 is 3. Plus 2 plus 1 makes 6. So the whole point to area between two curves is just simply you've got to think about the fact that you're looking at graphing it, shading in what it is against the axis based on x or y. Is it against the x-axis or y-axis, or between two curves because they went over the x-axis? And set up your integration, and y'all know how to do the integration part. It's just knowing how to set it up. You got to know about, is it top, bottom, left, or right? Because right minus left or top minus bottom. All right, to wrap this up, the very last piece of this set of notes says calculator. So first thing we need to do is we need to get out our 89, because I want to make this totally calculator. Uh-huh. So the first thing you're going to do is graph both of them in y equals to see where the shaded region is going to be. Okay? And if I personally, this is just me, but I'd multiply that out. Oh, thank you, sweetie. I would multiply that out because it's just easier to type in y1 and y2 if it's all multiplied out. And it'll help you later anyway, because if you multiply that out, you can set it up. So we're just looking to see who is going to be top minus bottom. That's what we're looking for. And what numbers do they cross on if they're not against the x-axis in the first place when they cross. It's weird? Probably not. It's probably weird.
So, is it the little tiny space? I think.
Hey, can I? Yeah, you got yours working?
What are you doing?
I don't know. Let me see.
Is it 0 to 1 or is it
Maybe. Might be 0 to 1.
So it's not a function.
But I didn't type it in. I didn't expand it before I typed it in.
You didn't type your times mark in there. You know how they're picky about that? I'll type it in for you. All right, so F. Okay, if we graph it.
0 to 1 and
I
then
didn't
1
see that
to
second one. I looked at the graph.
3.
Why don't you just prestigious schools?
Ooh. Okay. So we got a quadratic, and then we got
But they touch you.
up there somewhere.
Oh, it's beautiful.
I can't reach it. That's real crooked up there. Sorry, y'all. But it's got a little sliver right here at 0, 0 to where? 1. And then it's got a sliver from 1, and we got to get that intersection up there. That's why you want your calculator. So you can do second count number 5 and put it on each side of the intersection and get it. Because clearly from 0 to 1 is pretty simple. Everybody agree? Intersects at 3, 9? Anybody not think it's 3, 9? I don't have the answer to this one, or I could tell you. This is one of the few I don't have in my notes.
0 to 1 and 1 to 3.
1 to 3? Okay. Now, and again, you can use your calculator to help you find these intersections if you don't know where they are. Or you can look at the table. The y values will be the same. Who's on top? The quadratic or the cubic between 0 and 1? The cubic. All right. So then we'll put the multiplied out problem in there. Oh, wait a minute. Minus x squared. I forgot my minus x squared. Minus x squared. And notice I didn't put that in extra parentheses because minus one thing, you could just say minus one thing. And then in the other one then, does that make the quadratic on top on the rest of it? All right. So I'll put parentheses to show that because I know I got to put parentheses. Or I need to distribute that -1, right? I don't mean -1, but I mean I need to distribute a negative, correct? All right. So as you type this in your calculator, you can do that all in one big calculation. Did y'all know that you can do 2 integrations at one time?
I mean, I never tried it though.
So you can tell it to integrate and type your first formula, comma x, comma 0, comma 1, and then put plus, and then type the second one. So I want y'all to try that very quickly. Just type the whole entire thing at one time. Put your integration, put your problem, comma x, comma 0, comma 1, then put a plus sign, put your integration, type the problem, comma x, comma 1 to 3. But you got to put the parentheses in there to make sure it does the math right. because it's a little picky, which means you have to have an extra parentheses because the problem wants one already.
Chris, I swear, you type on those things faster than I can type on our actual keyboard.
Here.
Yeah, the answer, I'm barely on the first half. Yeah,
Now, it might be a little harder with some questions. You might have to, like, some things your calculator can't do. We might talk about that real quick. But the majority of it will do it all. But you also have to be able to do it by hand because it's on both portions of your AP test.
No. I got 37/12.
I didn't get 29/12.
I don't have the answer, so I can't tell you what's right. But I could look it up. Too few arguments means you're missing something that you need, like a comma X, or the two numbers is not getting in the right place because of parentheses. Like your parentheses aren't doing what they're supposed to be doing. I don't have the answer key book for this part of the textbook out. But we can talk about that some more in a little bit. All right. The last question on your notes is trig. And I am just going to show how to set it up and let y'all type it in the calculator because I'm running short on time. And then while y'all typing it in, I'll go look up the answer. All right, sine looks like this. Everybody agree? It's a wave that goes through the origin because it's an odd feature. And usually, this is negative 2 pi, this is pi, this is pi, and this is 2 pi, or its x-intercepts on each side of 0. Now, tangent, and of course it's too tall, meaning that it went up 2 and down 2 to be the amplitude. Everybody remember about amplitude? Okay, tangent has a break every half pi. So like, for example, well, I put that in the wrong place, hold on. Every half pi. So there's a half pi here, everybody agree? There's a half pi here, and there'd be a 3/2 pi over here, and there'd be a negative 3/2 pi over here. And it would look something like this. That's not a really good facsimile on the top half. Let me try that again. There we go. So we're going to focus our attention in the middle of this graph because the middle of this graph from here to here is what we really need to focus on. Because I could put another one over here. I could put another one over here, but it'd keep going on forever. So we just want to figure out, there was probably some extra information that came with this question. I don't remember. But anyway, so I need to know where sine and tangent have the same answer.
You know where sine and tangent have the same number.
Mm-hmm. Now, I can't put this in solver in my calculator because my calculator's not smart enough to tell me the answer is only between here. It would give me some kind of formula that would say I'm doing it a bunch of times. So let's think this through. First of all, let's think of all the numbers for tangent. Tangent can be 0 when it's 0 over 1, right? I'm just going to go up and look at the tangents on the first quadrant. Tangent would be 1 over the square root of 3, which is the square root of 3 over 3. Tangent would be 1, because the square root of 2 over 2 is 1. Everybody agree? And this one would be this, and then the other one would be undefined when I get to there. Now, this says I double sine to get that. So let's talk about the sines. The sine there is 1/2 that, the square root of 2 over 2, the square root of 3 over 2, and 1. Which one of those can I double and it'll turn into the one beside it? Can I double 1 to get 1?
No, I'm at 0.
Can I double 0? Okay, that's a possibility. All right, 0. Well, that makes sense. It crossed at 0. All right. Can I double 1/2 to get that? Can I double the square root of 2 over 2 to get 1? Can I double the square root of 3 over 2 to get that? Yep, because if you double that, don't the 2's cancel out? So that is pi over 3. Guess what? This is negative pi over 3. So that gives us some information to go on. Now, I want to use one of our rules we learned earlier to save a little time on this question. That's why I chose this one. What do you notice about these two slivers, if they were drawn correctly?
Symmetric.
They're symmetrical.
Oh, just like that. What is that?
Even odd rules? Even odd rules says do one of them and double it, right? So we could do from 0 to pi over 3 and double it, and it would give us both of them together instead of having to do, since one of them's all above and one of them's all below, right? And then, which one's on top in that first quadrant up here? Is it the sine or is it the tangent? It's the sine. So 2 sine of x minus tangent of x would be our formula that we're integrating. Now, when you type this in the calculator, don't put this ending parentheses right here, because you got to put comma x, comma, number, comma, number. And that 2 out here on this end is in front of the integration. And I'm going to pause the video. So in these problems, we're finding the length of an arc from A to B or C to D. You just got to know which letters it's about. A to B is all about x's, C to D is all about y's. But notice we don't put the original problem in here. We put the derivative in squared. That makes the power lower, might make some terms drop, might make it to where we can actually integrate. If not, it'll be totally a calculator problem. So I'm going to just draw out this first graph so we have something to go on and save us a little time. So this has a y-intercept of 4. Right, we only need half of it. And if I plug in 1, I'm going to get 3, and if I plug in 2, I'm going to get 0. So this is the half I'm talking about. And therefore, since this is a half I'm talking about, we're looking at, wait a minute, does this match y'all's pay problems?
Yep.
Okay, well, it doesn't match anything I've written on my paper. Okay. Don't know why. Oh, I see it now. Okay. So we're talking about all this little, no, we're not talking about area now. We're talking about arc length. We're talking about all of this down to here, right? So my line stops right there. That's how long it is. I'm trying to figure out how long is this arc. So I'm going to integrate from 0 to 2 because that's what my interval is. I've got a big square root with 1 plus a big parentheses that has a square on the outside, and all I need is the derivative to plug in. So that's right. So first we got to find the derivative is negative 2x. We plug that in. Right? We can square that in our heads and simplify that out to be 4x squared dx. Now here's why we can't do the rest of it on paper. That derivative is not sitting over here with dx, nor will it ever be, because the derivative of that's 8x, and I can't put an x in my derivative. It has to already be there. We can only put numbers. That makes you know it's a calculator problem. Does that make sense? Okay, so we would just integrate that on the calculator, and out will come the answer. While y'all are integrating that on your calculator, I am going to draw the picture for the next one to save a little time. When you plug in 1, you get 5/3, which is 2 1/3. And that's all it asks for. Wow, I should have plugged in. Well, okay. Wow, that was easy. It's a really small graph for number 2. What'd y'all get?
4.6.
Everybody agree?
Yeah.
All right.
647.
All right, so in this one they asked me to do it from 0 to 1, so it's not really straight, y'all, but it's such a small piece of a graph, it's hard to tell how to curve it. But I put in 0 and I got 1, I put in 1 and I got 5/3. Because 1 plus 2/3 is 5/3. So there's my arc. Now, if I take the derivative, if you put this 2/3 in front, what does that do with the 3/2? Cancels out, and then the power goes down by 1 to a half, and the 1 drops off. That's right, it's just a square root. Now, I've got 0 to 1, 1 plus x to the half power to 2, or I can write square root of x in there. It doesn't matter which one you do because half times 2 drops off also, right? So it's up to you if you want to turn to a square root. So then I'm integrating 1 plus x dx. What's the derivative of 1 plus x dx? 1. So that means that the derivative is there, right? So that the derivative of this has to be sitting over here, correct? Because this is chain rule. Since the last one wasn't, that's why we could go to the calculator. This one we can do by hand. So this is like saying there's a u in here and all of this is u and this is du, right? So I can integrate the square root of u to be u to the 3/2 with the 2/3 in front. Everybody agree? All right. And then I can put back in what I'm supposed to be doing with 1 plus x to the 3/2 and work it out from 0 to 1 by hand. Because I can do that. Kind of. I mean, you know, somewhat. Okay, so when you plug the 0 in, you're telling me 1 times that's just going to come out 2/3 for the back half. This part over here is a little trickier because that's 2 to the 3/2 power and 2 is not square rootable. Right? It's 2/3 times 2 to the 3/2 power. Everybody agree with that? So that's where you might end up getting a decimal answer for your question to finish it out because, well, I could take a 2/3 out. I don't know if that'll help me or not. Sometimes you might see something written like this if they want exact. If they see something they can take out, they'll take it out and just show the simplified inside. But otherwise, they want a decimal. If this was by hand, this would be the answer. If you were doing it totally on the calculator, you would have started way up yonder and just typed it in the calculator. All right. To wrap this up, let's see where I'm at. All right, I had a couple calculator ones to look at, totally calculator, I guess. And I have a Y one. All right, I think we're going to skip 3 and just look at 4 and 5. And these are going to be totally calculator. So in question number 4, we're looking at, we should be able to get the answer to this question fairly quickly. And we're just going to set these two up because I know y'all can type in the calculator, okay? But don't I need the derivative of dy over dx before I start? Couldn't I just type that in the calculator and get the derivative? How do I do that? Well, the derivative of 2 tangent inverse of x. Because you don't have arc on your calculator, you have inverse, right? Now, if this don't give me what I think it's going to give me, then we're going to go back and do formulas like we did before. Yeah, make sure you don't have anything stored in x. Because if you have something...
2 over x squared plus 1.
There it is.
2 over x squared plus 1, which makes sense if you think about it, because when we did the derivatives the other day, this is the one that didn't have the square root, right? And it had 1 plus u squared, and u is x. So that makes sense. And then it doubled it because the 2 was on the outside. Think that through. It was du over 1 plus u squared. Doesn't that make sense? Okay. Now that we've got that, we can integrate from 0 to 1 the square root of 1 plus that squared dx. We don't have to square it if we're putting it in the calculator. We just got to type it. Now, you can go back and type later. I want to just focus a few minutes on how to set them up. because I know y'all can type in the calculator. All right. Now, let's look at 5. And I may save surface area for tomorrow because I'm running a little short on time and I want to do some multiple choice stuff. All right, this is y, so that just means I got to type y's in my calculator when I'm doing the math. You with me so far? Okay? So first of all, what is dx over dy? I know that seems weird. How you take the derivative of v is write it down and do what? Derivative of the power. What's the derivative of the power? -1. Now let's set up our problem. We're setting up our integration from 0 to 2 because it's about y. We're going to say the square root of 1 plus our problem squared dy, and inside of there we're going to put this. Does that make sense? Do y'all feel like that just is simple enough that if you knew the formula you can do the math? It's not hard, is it? Now, if I do it by hand, it might take a while. Most of these are calculator driven because they can't be done by hand to get a final answer that makes sense. All right, I'm going to stop there on this packet. I'll finish this packet tomorrow. And I may change the order of what's up here on the board, but I'll still get it all done, but I might change my order a little bit. All right, next thing we're going to do is we're going to look at some, let me pause this.
We don't need